capabilities of weather satellites are rapidly improving and expanding, giving us an increasingly rich variety of imagery. There's perhaps no better way to showcase that variety than with hurricanes. So here's a tour of some unique satellite products using the two most recent, Danielle and Earl. I'll start with some imagery that looks familiar. This is a 90-minute visible satellite loop of Hurricane Danielle. The twist is that the images are just 1 minute apart, as opposed to the more typical 30. Look at the amazing detail that's unveiled with this minute-by-minute scan. You can literally watch individual thunderstorm cells bubble up near the center and in the spiral bands of the hurricane. A week later, here's a visible loop of Hurricane Earl with images taken just 5 to 10 minutes apart. Notice that most of the bright white, thick clouds were spiraling counterclockwise and inward toward the center. But around the periphery, high-altitude, thinner clouds were moving outward. A subtle clue that high pressure aloft was helping to vent the storm and keep its pressure low by moving air away from the center. Now for some less conventional imagery. This looks a lot like water vapor imagery, but it's called total precipitable water. It's an estimate of how much water you could squeeze from the air if all the moisture instantly fell to the ground. Here, the deepest maroons correspond to about 3 inches, the purples less than 1. Notice the drier air being wrapped into Earl as it neared the North Carolina coast. Total precipitable water is related to rainfall rates. That's what this product shows from a different satellite called TRMM, short for Tropical Rainfall Measuring Mission. Here, green correlates to about 1 inch per hour, orange about 1.5 inches. Basically, this is a radar image from space, especially useful when hurricanes are out of reach of the land-based Doppler radar network. Finally, by blending data from multiple satellites, here's a product that focuses on the structure of the heaviest thunderstorms, most notably the ones in the eye wall, the ring of heavy weather surrounding the eye. This is 36 hours in the life of Earl via what's called Morphed Integrated Microwave Imagery, MIMIC for short. This MRI-like perspective allows us to watch the eye wall evolve, a process that's closely tied to changes in hurricane intensity. In fact, this product provides a unique look at a complex process called an eye wall replacement cycle that controls fluctuations in a hurricane's strength. Here we can actually watch this happen with Hurricane Danielle. At the start, you see a small eye surrounded by a ring of thunderstorms, the eye wall. Over time, that small ring begins to collapse and become less prominent, while a larger outer ring, a new eye wall, begins to form. Eventually, the inner ring basically disappears, and the outer ring takes over as the new eye wall. During this replacement cycle, the hurricane weakens, and this special imagery gives unprecedented access to this still poorly understood process. One of the issues with some of these images is that they're not necessarily available in real time, but even after the fact, they are proving increasingly useful, and not just with tropical cyclones. Fred is back with the extended forecast next.
3:17.
Damn.
And you were flying.
Yeah, I don't think I